Welcome back to Database Internals Crashcasts. I'm Sheila, and I'm here with Victor to wrap up our chapter on data modeling. Before we dive in, I'd like to remind our listeners to rate our podcast on whatever platform you're using. Your feedback helps us improve and reach more database enthusiasts.
That's right, Sheila. We've covered a lot of ground in this chapter, from entity relationship modeling to converting those models into relational structures. Today, we'll be summarizing the key points and tying everything together.
Excellent. But before we get into that, I have a quiz question for our listeners. Here it is. In a university database system, a student can enroll in multiple courses, and each course can have multiple students. What type of relationship is this, and how would you represent it in an ER diagram?
Ooh, that's a great question, Sheila. It really gets to the heart of what we've been discussing in this chapter. Listeners, take a moment to think about it. Consider the entities involved and how they relate to each other. We'll reveal the answer at the end of the episode, so stay tuned.
Now, let's start our summary by revisiting the concept of data modeling. Victor, could you give us a quick refresher on what data modeling is and why it's so important in database design?
Certainly. Data modeling is the process of creating a visual representation of either a whole information system or parts of it to communicate connections between data points and structures. It's like creating a blueprint for a building, but instead of rooms and walls, we're dealing with entities, attributes, and relationships.
I like that analogy. So, just as an architect's blueprint helps construction workers build a sturdy and functional building, a data model helps database designers create an efficient and effective database system, right?
Exactly. And just like how a poorly designed blueprint can lead to structural problems in a building, a flawed data model can result in inefficiencies, data redundancies, and difficulties in maintaining and scaling the database.
That makes sense. Now, we spent a good deal of time discussing entity relationship modeling. Could you summarize the key components of ER modeling for our listeners?
Of course, ER modeling consists of three main components: entities, attributes, and relationships. Entities are objects or concepts about which we want to store information, like students or courses. Attributes are the specific pieces of information we want to record about each entity, such as a student's name or ID number. Relationships describe how different entities interact with each other, like enrollment between students and courses.
And we represent these components visually in ER diagrams, right? With rectangles for entities, ovals for attributes, and diamond shapes for relationships.
That's correct, Sheila. ER diagrams are a powerful tool for visualizing the structure of a database. They help stakeholders understand the data model without needing to delve into technical details.
Now we also covered the process of converting ER models to relational models. Could you walk us through that process briefly?
Certainly. The conversion process involves translating the conceptual ER model into a logical relational model. Entities typically become tables, attributes become columns in those tables, and relationships are represented through foreign keys, or, in the case of many-to-many relationships, through junction tables. For listeners unfamiliar with the term, a foreign key is a field in one table that refers to the primary key in another table, creating a link between the two.
I remember that many-to-many relationships can be tricky. That's actually relevant to our quiz question, isn't it?
Good observation. Yes, many-to-many relationships, like the one in our quiz question, require special attention. But let's not give away too much about the answer just yet.
Fair enough. Now, data modeling isn't without its challenges. What are some common pitfalls that database designers should be aware of?
Great question. One common pitfall is over-normalization, where designers create too many tables in an attempt to eliminate all data redundancy. This can lead to complex queries and poor performance. Another is inadequate planning for scalability, which can cause problems as the database grows.
Those sound like serious issues. Are there any best practices you'd recommend to avoid these pitfalls?
Absolutely. First, always start with a clear understanding of the business requirements. This helps ensure that your data model aligns with actual needs. Second, involve stakeholders early and often in the modeling process. Their input can be invaluable. Third, consider future scalability from the start. And finally, don't be afraid to iterate on your model. It's rare to get it perfect on the first try.
That's great advice, Victor. You know, I recently read about a case study where a large e-commerce company completely overhauled their database design. They went from a rigid, over-normalized structure to a more flexible model that better accommodated their rapid growth. It dramatically improved their system's performance and scalability.
That's a perfect example of why good data modeling is so crucial, Sheila. It can make the difference between a system that struggles to keep up and one that supports and even drives business growth.
Absolutely. Now, speaking of growth, I think it's time to reveal the answer to our quiz question. Victor, would you like to do the honors?
I'd be happy to. The relationship described in our quiz question, where a student can enroll in multiple courses and each course can have multiple students, is a many-to-many relationship. In an ER diagram, we'd typically represent this with a diamond shape connecting the student and course entities. We'd use crow's foot notation on both sides of the diamond to indicate the many nature of the relationship on both ends.
Excellent explanation, Victor. To wrap up our chapter on data modeling, let's summarize the key points we've covered. Point 1. Data modeling is crucial for designing efficient and effective database systems. Point 2. Entity relationship modeling is a powerful tool for visualizing data structures. Point 3. ER models can be converted into relational models for implementation. 4. Common pitfalls include over-normalization and poor scalability planning. 5. Best practices involve understanding business requirements, involving stakeholders, planning for scalability, and iterating on your model.
That's a great summary, Sheila. I hope our listeners have found this chapter on data modeling informative and useful. Remember, a well-designed data model is the foundation of any good database system.
Absolutely, Victor. And to our listeners, we hope you've enjoyed this deep dive into data modeling. If you found this helpful, please visit crashcasts.com and consider joining our Discord community. Your support on Patreon helps us continue creating these educational episodes. Don't forget to subscribe to the podcast and rate us on your preferred platform. Until next time, happy modeling.